So to find the area of this problem, we're going to go ahead and draw a rectangle. Remember that our area is the base times the height of a rectangle. And in this case, the base is going to be a small change in x. So we just need to find the length of the height. So it's going to start here and go all the way down. So it's going to be the top minus the bottom, where the top curve is going to be y equals 2x, and the bottom curve is going to be y equals x squared. So for part A, we're going to sum the area of all the rectangles. So it's going to be 2x minus x squared. That would give me the height of my rectangle. The base is dx. And I'm going to be going from 0 to 2. So the antiderivative of 2x would be 2x squared over 2. Antiderivative of x cubed is x squared is x cubed over 3. And I'm going from 0 to 2. Substitute the 2. So I'm going to have 4 minus 8 over 3. You need to be very careful. You always need to substitute to 0. In this case, when I substitute to 0, they're both going to be 0. So 4 minus 8 thirds would give me 4 thirds. So my area would be 4 thirds. For part B, it tells us that the region is the base of the solid. For this solid, each cross-section is perpendicular to the x-axis, has an area of sine pi 2x. We need to find the volume of the solid. So we don't know what kind of figure this shape is or what's on top of my base. All I do know is that it's perpendicular to the x-axis, so it's going to be vertical, so that means it's going to be a small change in x. And remember to find volume. The volume is always the area of the figure, which we call big B, times h. In this case, h is going to be a small change in x. And we're already given what the area of the figure is. The area of the figure is given by sine of pi over 2x, and h is going to be a small change in x. So I already know what the area is. So to find the volume of all the figures, I'm going to have to do the integral because I'm summing the volumes of all the cross sections together. And since it's dx, once again, I'm going to be going from 0 to 2. So the antiderivative of sine is negative cosine. Everything has to stay the same. But when you take the antiderivative of sine, we're going to let u be pi over 2x. So du would be pi over 2 dx. So 2 over pi du would be dx. So I need to multiply my answer by 2 over pi. And I'm going from 0 to 2. So I'm going to have negative 2 pi cosine of pi over 2 times 2 minus a negative cosine of 0 times 2 pi. So my 2's are going to cancel, so I'm left with cosine pi. That gives me negative 1. So I have 2 over pi plus cosine of 0 is 1. So 2 over pi. So that gives me 4 pi. For part C, we have another cross-section, but this time our cross-section perpendicular to the y-axis. So that means they're going to be horizontal, are squares. Okay, so we're not just going to write, we're not going to evaluate this volume. So now the cross sections are going to be horizontal. That means I'm going to have a small change in y. and my volume is going to be the area of the base times the height. This time though, the base are squares. And I know that since it's a square, the area of the square is going to be base squared. So what I need to do is I need to find what the length of this base is, or of this length. And the length, which is going to be this, and since it's horizontal, it's going to be the right length minus the left one. But because it is horizontal, I need to write all my equations in terms of x. So this one's going to become x equals, or in terms of y, sorry, I need to solve for x. So this is going to be x equals the square root of y. And y equals 2x would become x equals 1/2 y. Okay. So the base of the square, or the length, is going to be the square root of y minus 1/2 y. So the area is going to be the square root of y minus 1/2 y squared. So remember, we just need to write the integral. We don't have to evaluate. So my integral is going to be the area of the base, which is the square, times the small change in y. And now my upper and lower bound, since everything has to be in terms of y, it's going to be going from 0 to 4. For part C, now what we're going to do is we're going to revolve this region around the x-axis. So I'm revolving it around the x-axis. So that means I'm going to have, okay, so this is going to be the center of my cylinder. So notice that there's a gap in between. So this is going to be a washer. I have a big cylinder and a smaller cylinder. So I need to find the volume of this cylinder. So just like the other ones, the volume is going to be the area of the figure times the height. Because it's horizontal, the height is going to be a small change in x. So I just need to find the area of the figure, and the figure is a circle. So that means that my volume is going to be pi r squared times the small change in x. So I need to find the radius of the circle. But because it's a washer, it's going to be, my volume is going to be big R and subtract the smaller cylinder, or the volume of the smaller cylinder. So in this case, big R is going to start at my center and go all the way up. So it's going to be the top curve, which is 2x, minus the bottom curve, which is 0. Little r is going to start at the center and go to the smallest one. So that's going to be x squared minus 0, or x squared. So my volume is going to be pi big R, which is 2x squared, and that's the volume of the big cylinder. So now I need to find the volume of the smaller cylinder. Okay, and that would be subtract volume of the smaller cylinder. So they both have a pi. I'm going to go ahead and factor out a pi, and I'm going to have 4x squared minus x to the 4th dx. And because it is horizontal, I'm going to be going from 0 to 2. Okay, so my antiderivative is going to be 4x cubed over 3 minus x to the 5th over 5, and I'm going from 0 to 2. So I'm going to have 4 times 8 over 3. or 32 over 5. And then if I substitute 0, I get 0. And this would give me 64/15